right, so number 6. All right. There will be a question like this on your test. This is just solving an exponential. Anytime we have these exponentials, you have to get the part with an exponent by itself first. Like on number 5, you had to subtract the 7 to have that 8w by itself. Here, I need that 4 to the 5t by itself. So what do I need to do? Divide by 3. So we have 4 to the 5t equals 100 over 3. Yeah, you could give me the decimal. I prefer not to round. If you made a mistake, please fix it as we work through these. So then, what do we need to do? Add a log. If you cannot get the same base, you add your log to each side. The reason we like logs is because that exponent comes down. So we have 5t log of 4 equals the log of 100 over 3. Then if I want to get t by itself, what do we have to do? So we have log 100 over 3 divided by 5 log 4. On the test, I am not going to specify if it has to be the exact answer or not. In other words, you can leave your answer like this, or you can give me the decimal. Okay, if you plug this all in, you need parentheses around the entire denominator. It turns out to be 0.5059. But on your test, I will accept either one of those. You do not have to do the decimal if you don't want to. All right, is that one okay? All right, we didn't ask about 7, so that one was all right. 8 is very similar. Okay, so when I look at this, can I get a common base? No, so we add logs. When we have e, what do we use? Natural log. Okay. You don't have to, but it makes things easier because anytime you have a natural log and an e, they drop. So we have negative 4x minus 1 equals s natural log of 5. You need all of your x's on one side, so we have to add over the 4x. Then what could we do?
Take out the x.
So we get the natural log of 5 plus 4. So then to get x by itself,
Divide by that.
okay. So again, I will accept this. If you want to put it in your calculator and give me the decimal, you can do that as well. And that turns out to be negative 0.1783.
I got something different, but I did it a different way. I subtracted over the x to the negative 4, and I got natural log 5 plus 1 over negative 5. Because I divided negative 5 over.
Killing.
So then we got into the log problems. We have two types of logs, or two types of log problems. We have ones where everything has a log, and we have problems where only some things have a log. Either way, though, you have to start by condensing. If you have these two logs added, how do you put them together? Then, it's legal to add a log to both sides or to take it away from both sides. If it's only on one, the only way to get rid of it is to change it into an exponential. The base of a natural log is e, so this means e to the third power equals 6x. So then to get x by itself, you just divide by 6. So again, you can give me this for your answer, or if you plugged it in, it's 3.3476. I will accept either one on your test.
You got 13 on there?
Nope. So this problem, there are a couple different ways to do it. I think most of you just started out by changing it into exponential form. I know at least one person did evaluate log base 7 of 49. What is that?
2.
2. It's like saying 7 to what power equals 49. So if you caught that, you could go ahead and change this to a 2 and then just solve.
Why?
If you didn't, you have a log on one side only, so you change it to exponential.
You can come at base.
And we can get a common base. We don't need logs to solve this. 49 is 7 squared. So 3x minus 4 equals 2. So x equals 2. And I failed to mention, but make sure you're checking these log problems. Your argument has to be positive. So number 12. This one wasn't pretty, but we can do it. Okay, we have to start by condensing. If you have 2 logs subtracted, how do you put it? So log base 3 of x squared over 7. Eli, you're taking your test on a little bit. Are you paying attention? So if there's a log on one side, what do we do?
Change it. Yeah, I forgot what it's called.
So 3 to the 12 equals x squared over 7. Then what do you do?
Check 7.
You can multiply 7.
Multiply by 7.
I see it's a check. I'm in one.
This is a huge number. I'm just going to leave it like this for a second.
It is quite big.
Yeah. I don't have a calculator in my hand, so I'm just going to leave it. How do you get rid of a square?
Square root.
With that, you do plus and minus. And so you get positive and negative 1,928.7527. But can your argument be a negative?
No.
No. So your answer is just be positive.
Yes, it is. That was a big number.
Yeah, that one was not very pretty. All right. Number 13. So this takes us into the third type of problem, where everything has a log. You start first using properties of logs. If you have a coefficient, what do you do with that?
Exponent.
So that's the log of x squared.
Dropping it on.
Now if you have a log on each side, you can just drop them. So this is a quadratic. We need to set it equal to 0. So subtract 7x, add the 12.
Negative 4 and negative 3.
So x equals 3 and 4. So what do we have to do?
Check.
Check. So you're checking that these arguments are positive. If we plug a 3 in, 21 minus 12 is positive, 3 is positive, we're good. If we plug in 4, 28 minus 12 is positive, 4 is positive. So this time both answers do.
There we go.
What did you add?
Okay. So if I have 2 logs added, how do we multiply? To multiply those two parentheses, you have to FOIL, so you get x squared plus 3x plus 4x, that would be 7x plus 12. If you have a log on one side, what do we do?
Gotta add more.
No.
Change it to
Exponential.
Okay, 2 to the first is just 2, so we can subtract that over.
Bam.
So then we can factor. What multiplies to 10 and adds to 7?
5 and 2.
Set those equal to 0 and we get negative 2 and negative 5.
Negative 5.
Right. Negative 2 plus 3 is positive, negative 2 plus 4 is positive, so that's good. But negative 5 is not. So negative 2 is the only answer here. Number if logs are subtracted,
They have to be copied.
so that's going to be the natural log of x minus 1 over x plus 6 equals the natural log x minus 2 over x plus 3.
And then
Excuse
you take those natural logs out.
Since it's on each side, you can cancel it.
And then you cross multiply.
The butterfly method.
Okay. So when I multiply these two, we FOIL, we get x squared plus 2x minus 3. Multiply those two, we get x squared plus 4x minus 12.
That's no thing.
So if I subtract over my x squared,
It's
Cancel.
that's nice. So then if I subtract over my 4x,
it's negative 2.
add my 3,
It's negative.
so x is 9 halves. Check. 9 halves is like 4.5. 4.5 minus 1 plus 6 minus 2 plus 3. Those are all positive. So that answer works. Number 17. So this will definitely be on your test. And you will have to show me work. In other words, if you just write down the final answer, you don't get anything. Okay? When I ask you to use the change of base is log of the argument, or log of the big number, divided by log of the small number. So this is what you have to write down. Then you plug that in your calculator to get your final answer.
So when you wait, how I need to say it. So, alright.
All right, so everybody knows the change base?
Yeah, that was the easiest one.
Okay. Number 19. Probably going to have one of these word problems on here. So I told you I would give you your interest formulas. You don't have to memorize that. You just have to be able to use it. So 18 and 19, they're both interest. I'll do probably only one question on the test, but one of those two. So I gave you your formula. I want the doubling time. So did I tell you how much you started with?
Nope.
So give me an amount. What do you want to start with?
2.
Then if you double, you end with?
4.
Okay. Compounded semi-annually, so that's 2 times per year. Your rate is 3%, so 0.03. You are trying to find t. So my a is 4, b is 2, 1 plus 0.03 over 2 to the 2t power. Divide over the 2. 1 plus 0.03 divided by 2.
Is no, it's 1.00.
Now this is like a question that I would have given you on 5 through 9. We can't get a common base, so what do we do?
Log.
Add the log.
Does it matter which one?
No.
So we have log 2 equals, exponent comes down.
And I got 1 point for you. Oh, the first time I did this, I got 0.95.
When you plug this in, remember every time you push a log, it opens a parenthesis, you have to close it. You also need parentheses around the denominator.
Because I didn't add logs.
I did something like way off.
Yeah, Reese.
Okay.
The doubling time.
Meow.
But please put less than you.
20.
Oh, come on. That one's easy.
All right, expanding and condensing. So what you have to remember,
Is it, if it's on top, you're
Hey,
adding?
can you look?
this had a
Teaching too.
square root of z. A square root is what power?
Where? Get a little ahead of me.
Okay, so we have log base 5 of x squared, so the 2 goes in front. Everything on the top gets added, so plus log base 5 y to the 5th, so
5 what? 5 you know what I mean.
yes, I do. Next one, we have log base 5 of z to the 1/2, so I can bring the 1/2 in
Could
front.
you keep it as a,
As the square root, I would probably take off for not recognizing that the square root is just a power and bringing that down.
well, now I
It's
know.
not that hard, Reese.
Both of these are on the bottom, so both of those will be subtracted. So minus log base 5 of a, so the 4 comes down, minus log base 5 of p to the 7th, so the 7 comes
Pushing P,
down.
man.
Alright, is that one okay?
Wait, I thought like
What games are
on the
That's
Come
ridiculous.
on, man.
I think they just read.
like with how they're both like the denominator, I thought it was like these.
So they are, if you think of it that way, it's like the top minus the bottom. So you could have also written it like this.
Okay, that's how I normally write it.
Yep, as long as you have those parentheses, that's okay.
Okay.
Other questions?
Oh, good.
All right. B. We have the natural log of 3x over x cubed minus 1. So on the top we have two things multiplied, so you break them off. Natural log of 3 plus the natural log of x. Minus, on the bottom we have the natural log of x cubed minus 1. Can you break apart subtraction?
No.
No. Since that cube doesn't go to everything, you can't drop it down, so that's my final answer.
Noted.
All right. So you can do the expanding. Let's condense a couple. So the first one.
It's like a triple winner.
First one could go. Huh.
You like a win-win, man.
All right, so coefficients turn into exponents. So this will be a cube, this will be a 4. We have the log one time. We have the x minus 1 cubed. Both of these were subtracted, so they both go on the bottom. And it doesn't matter if you put the x in front of that parenthesis, or either one is fine.
So it would be divided again?
You could write it as this and then divided by x, it's just uglier. Basically, if there are multiple things subtracted, just put all of them on the denominator.
What's technically right?
This is the best answer, the most
Would you
simple.
count off if I did it like that?
How did you have it written?
Like, I just divided by x.
Yeah, it's equivalent
You put Tom there? I put Tom.
because they're both on the bottom, so it's, another way to think of it is if you pull out that negative, then that will become a positive, so those two are multiplied together on the bottom. So B, we have 1/2 log base 2 of x plus 3 log base 2 of 5 minus log base 2 of 7y. So exponents, or coefficients turn into exponents. We have the log base 2. So we have x to the 1/2 plus, so times 5 to the 3rd minus, so divided by 7y. And you could leave it like that. You could change the top to 125 x to the 1/2 or 125 square root of x. All of those things are equivalent. We didn't ask about 22, but you know if I ask you to find the domain of a log, you just have to take whatever's on the inside greater than 0. All right, 23. So this is just using a formula. It tells us that pH is negative log H3O+. I would give you the formula, you just have to be able to use it. So on the first one, I said find the pH if the H3O+ is 1.8 times 10 to the negative 4. So you are just putting this in your calculator. Negative log 1.8 times 10 to the negative 4. And that gives us, we usually just went to one decimal. If you did more, that's fine. So it comes out to be 3.7. B, I gave you the pH. That's 8.6. You have to solve for this other piece. So what do you need to do with the negative, first of all?
Divide.
Then if you have a log on one side, how do you get rid of it? Exponential. This is a base of 10. So 10 to the negative 8.6 equals this H3O plus. So 10 to the negative 8.6. It gives me 2.5, and then at the end, E negative 9. So that's 2.5 times 10 to the negative 9.
So when we do this, do we have to do it in scientific notation?
Yeah, that's what your calculator is going to give you when you plug it in. So just look at the very end. It'll say E and then a number. That's what goes on the 10. All right. 24. Let's talk about graphing. So we always change these to exponential. This means 4 to the y equals x. So if you make your t-chart, exponentials, we always put in 3 points for the exponent, which is my y. 4 to the negative 1 is 1/4. 4 to the 0 is 1. 4 to the first is 4. So 1/4 negative 1, 1 0, 4 1. Remember the log, your argument has to be positive, so this is just kind of like a vertical asymptote right here. So it looks like that. On B, same idea. Change it to an exponential. So it's 1/4 to the y equals x. So if you make your t-chart, you're plugging in for y. 1/4 to the negative 1 is 4. 1/4 to the 0 is 1. 1/4 to the first is 1/4. And then plot your points. Is that one okay? C is log base 4 of x plus 1. Easiest to do this with transformation. Didn't we already graph log base 4 of x on the first question?
Yeah.
So if I took those points, we had 1/4 negative 1, 1 0, and 4 1. So that would be your parent function. What does the plus 1 do?
Left.
So if I take each thing left 1. And then your asymptote moves as well. So my asymptote is now at negative 1. And that's my point there.
On that, you want the parent function, right?
I would like it, yes. We okay on the graphing? Change them to exponential, do a t-chart. The last ones. I said without a calculator, meaning I don't want you just finding on your calculator plugging in log base 3 of 81. I want you understanding what these logs mean. Log base 3 of 81. What that means is 3 to what power equals 81? Or if you set that equal to x, that's like saying 3 to the x equals 81. And that's 4. You could write it as a common base if you wanted to show all your work, but we get a 4. So on B, log base 3 of 1/3. You could set it equal to x and work it out, or you could ask yourself, 3 to what power equals 1/3?
-1.
Negative 1. Do I need to work that out? So C, log base 10 of 0.01. 0.01, if you read that as a decimal, that's 100. That's like 1/100. So 10 to what power would be 1/100?
-2.
Because 10 squared is 100. To move to the bottom, it has to be a negative. D, log base 6 of the square root of 6.
Which is 6
Right. If you need to set that equal to x, you could. This is like 6 to the x equals the square root of 6, but we know a square root is just a 1/2 power. So that's 1/2. So you may or may not have shown work on these. E, log base e of 1. E to what power equals 1?
0.
0. Anything to the 0 power is 1. F. This one you may have needed to work out. So if you set that equal to x, that says 3 to the x equals 27 to the 3/2. 27 is 3 to the 3rd. What do you do with a power to a power?
more.
So that's 3 to the 9/2. So x is 9/2. So we have the pH. You have to move the negative to the other side. Then the only way, if there's only a log on one side, you have to change it to exponential. The base on this log is 10, so you get 10 to the negative 2.4. And when you put that one in your calculator, it may not have given you scientific notation, which is fine. So you get 0.00398. If you said 0.004, I would take it. If you said 4 times 10 to the negative 3, I would take it. Any of those answers are fine. Number 2, giving the domain of a log. What do you have to do?
Say equal, or greater than 0.
So we get x is greater than 4, so that would be 4 to infinity. Paying attention? All right, number 3, doubling time. So give me a starting amount.
2.
And we end with,
Well,
my rate is 0.035. So now what?
Divide the 2. Add natural.
Natural log is nice because those cancel. So we divide by the 0.035. So you get about 19.8 years. Are those okay?
Jeez.
All right.
Is it always gonna be years?
Yes.
Unless it say otherwise.
Yes. Let's try a couple log equations. So what would I do on the first one here?
You change it to x squared minus 2x.
Okay, we have to always start by condensing. If these logs are added, when you put them together, you multiply. So x times x minus 2, 3x squared minus 2x equals 1. So then if the log is only on one side, change to exponential. So 3 to the first equals x squared minus 2x. Then we can set it equal to 0. What multiplies to -3 and adds to -2?
-3.
So we get x to be 3 and negative 1. Do both answers work?
Just 3.
Yes, with it. Okay. So condense first, and then if there's only a log on one side, we change it to exponential form. Number 5, what do we need to do?
Distribute the 3.
Since these things are added, you multiply. So 3 times 2x plus 4.
6x plus
Then we have one log on each side.
4. There you go.
And just drop them. So we get 11 equals 3x. X is negative 11 over 3. Does that work? When you put it in, negative 11 over 3 times 3 is negative 11 plus 1 is negative. So if that doesn't work, what do we have to say?
No solution.
No solution.
No solution. All right. Let's practice a few more. So we just reviewed basically there's only 2 types of log problems. Either log on one side or log on both sides. Exponentials. Let's say I gave you that. These were about the hardest exponential problems I could give you because we had multiple x's in our exponent. What did we have to do?
Add a log.
Add logs.
When you do that, the exponent comes down. So now what?
Distribute.
So 1 times log 2 is log 2. Negative 3x times log 2 is minus 3x log 2. So now what? Final step to get x by itself.
Divide it all.
And I told you you could plug it in your calculator, but I will also accept it if you just want to leave it like this.
Wouldn't we subtract it over it?
It was a negative.
Oh, okay, you did the log 2 first.
Yeah. All right. Got 4 minutes. Should I do another one?
No.
Do you guys remember if it starts with an E, what should you add? Natural logs. Remember, always isolate your log first. So we did that one you guys asked about that was something like 2 times 3 to the x plus 4 equals 5. So what would you do first there?
Divide 2.
Divide by 2 and then